Hello students, this is Prabhas Sharma, Assistant Professor, Department Electronics and Communication, Oriental Institute of Science and Technology, Bhopal. Today my lecture topic is Pulse Amplitude Modulation, PAM. This topic comes under the subject Digital Communication. Pulse Modulation. In the analog communication subject, we have studied about the analog modulation techniques, amplitude modulation, frequency modulation, and phase modulation. These are the continuous wave modulation. For the next division is pulse modulation. The pulse modulation is further divided into analog and digital modulation. If the massive signal is analog, carrier signal is analog, then the resultant signal is also analog. This is known as continuous wave modulation. And if one of the signal from message or carrier is digital or pulse, it is known as digital modulation or pulse modulation. If message signal is analog and carrier signal is digital, then this is pulse modulation. And if the message signal is digital and the carrier signal is analog, it is known as digital pulse modulation, or known as data transmission techniques. The analog modulation techniques are mainly classified into pulse amplitude modulation. Second is pulse duration modulation or pulse width modulation. Third is pulse position modulation. So first is pulse amplitude modulation. In the pulse amplitude modulation, in which the amplitude of the pulse carrier wave varies in accordance with the amplitude of the massive signal, whereas width and the position of the pulse signal remains constant. The pulse amplitude modulated signal will follow the amplitude of the original signal as the signal traces out the path of the whole wave. The pulse amplitude modulation. The pulse amplitude modulation is based on the concept of sampling. So as we know that there are two types of sampling, natural sampling and flat top sampling. So PAM is also of two types, natural and flat top. The first is natural sampler circuit. We are generating PAM by using natural sampler circuit. In the natural sampler circuit, we use a FET. FET as a switch which used as a sampling gate. When this FET is on, the analog voltage is shorted to ground. And when the off, the FET is essential open, so the analog signal sample appears at the output. We are using a op-amp as a non-inverting amplifier that isolates the analog input channel from the switching function. This is the natural sampler circuit, op-amp 1 and op-amp 2. In the first op-amp, the analog input, we are applying the analog input. Output of op-amp 1 is going through the switch and the output of switch is going to the op-amp 2. From the switch, we are applying the train of pulse. We are multiplying the analog signal with the train of pulse. The output of op-amp 2 will give the natural sample or known as natural PAM signal, where the amplitude of the train of pulse is changing with respect to the amplitude of the massive signal. यहाँ पर amplitude change करेगा according to the massive signal. It is known as PAM, pulse amplitude modulation, and the amplitude is naturally increasing or decreasing, and it is known as PAM natural sampling. PAM natural sampling. Op-amp 2 is high input impedance voltage follower capable of driving low impedance loads. The resistor R is used to limit the output current of op-amp when the FET is on and provides a voltage division with RD of the FET. Now the PAM of flat top sampling. The most common technique for sampling voice in PCM system is sample and hold circuit. In this circuit, first we sample, then hold that amplitude for the period. This is a circuit of flat top sampling. In the flat top sampling circuit, the instantaneous amplitude of the analog signal is held for the constant charge on a capacitor for the duration of sampling period Ts. This technique is useful for holding the sampling constant while other processing is taking place, but it alters the frequency spectrum and introduces an error known as aperture error. In the flat top sampling, the amount of error depends on how much the analog changes during the holding time, called aperture time. To estimate the maximum voltage error possible, determine the maximum slope of the analog signal and multiply it by the aperture time. This is the circuit of flat top sampling, which is same as the natural sampling, only the changes of capacitor. The capacitor hold the charge for the particular time, so we get the holding output. Okay, again here we are using there two op-amp 1 and op-amp 2. The difference is only a capacitor or hold capacitor. The circuit is known as sample and hold circuit. This is the diagram of unipolar and bipolar PAM, pulse amplitude modulated signal, unipolar and bipolar. As we all know, unipolar above the axis, bipolar above and below the axis. Recovering of original signal MT from the PAM signal. The PAM signal passes through a reconstruction filter, which is normally a low pass filter. Then it is passes through an equalizer and we get the message signal MT, where the filter bandwidth is omega. The filter output is 1 by MF into HF. Note that the Fourier transform of ST is given by HF, which equals to T of sinc of FT multiplying with exponential function. The aperture effect. Let the equalizer response is 1 by HF, which is equals to 1 by T sinc function, which is equals to pi f by sine pi ft. Ideally, the original signal MT can be recovered completely by using this filter. In the PAM, the amplitude of the pulse signal varies in accordance with the message signal, whereas the width and the position of the pulse signal remains constant. Only the amplitude changes. Thank you for this video. For more details or your doubts, you can call me or you can write me mail.